Okay, good afternoon, 8th and 9th grade science. This here is, you should watch this video before you do the test to check your study guide. Now, if you do not have your study guide completed, stop the video now. Stop. Complete your study guide and then come back. So, again, this will be the answers to study guide. It will also be a help for you to study for test. For 8th and 9th grade science. We're on study guide number 13, and so I will start with giving you the answers for the first terms. So if you are on the first page, it should be 339. Well, that's in the textbook. I don't know what it is in your workbook. The first one is model. It's a schematic description of a system that occurs for its known properties. Oh, that accounts for its known properties. It'd help if I'd read it correctly. A systematic description of a system that accounts for its known properties. Nucleus, the center of the atom containing the protons and the neutrons. If you see here on the board, the nucleus is this little part right here that contains the protons and the neutrons. Atomic number, the number of protons in an atom. The atomic number is, if you look at your chart, is the number of protons in this atom, and that will also be the number of electrons around the outside. Now, not the number of the nucleus. Not the number of the nucleus. The nucleus is here. The protons and the electrons have the same. So when you see the atomic number, it will be the same. D, the mass number, number D, 1D, mass number. The sum of numbers of neutrons and protons in the nucleus of an atom. Okay, now the mass number, that's the big number. That's all these guys added together. Okay, so if you are back here doing on your chart, which you will need to use this chart for your thing, you can see the top number is going to be your atomic number. Your top number is going to be the number of protons and the number of electrons. That's the same. And then your mass number is that little number down in the bottom. It is at the bottom of your thing. It's at the bottom of your boxes. And it's not even, a lot of times it's a decimal. It's not even a complete number. That is a mass number, is the number of these guys added up. Okay? So if you want to know how many neutrons there are in here, all you have to do is subtract the atomic number, from the mass number, and that will tell you how many neutrons there are. And sometimes they'll be the same amount, but not always. Sometimes the protons, the neutrons, and the electrons will all be the same number, but sometimes they'll be different. Yeah, that was just a little extra. Hopefully you understand. The isotopes, E, means atoms with the same number of protons but different number of electrons. Isotope is when you have a different number of electrons than what you do protons. An element is a collection of atoms that all have the same number of protons. An element is a whole collection of them, guys. And radioactive isotope is an atom with a nucleus that is not stable. Okay, this nucleus is not stable. It can change through decay, alpha decay, beta decay. We'll let that. And G, radioactive isotope is an atom with a nucleus that is not, I told you that one. H, half-life. The time it takes for half of the original sample of the radioactive isotope to decay. Now that half-life, I guess maybe this would be a perfect time to explain it. You have test questions on this, and you need to understand that the half-life decay is if you have a certain element and it decays in, let's say, I'll use this example, the half-life is 5 years. Okay? In 5 years, and we start out with I'll make this real simple, we start out with a 10-pound block. In 5 years, half of it be gone. So what will you have? 5 pounds left. And in the next 5 years, half of it's gone again. So you say, oh, it's gone, total. No, only half of the 5 pounds. Okay, so now you have half of 5 is 2.5. Now you have 2.5 pounds. And so then the next 5 years, half of that's going. And the next 5 years, half of that going. So every time it just keeps getting smaller and smaller and smaller and smaller and smaller. But you still just lose half of it. However lifespan it has for a half-life, every time you just lose half of it. If you don't get it, call me. You need to know that. Number 2 is this. Order the 3 constant quantum from the least mass to the most mass. Okay, you should have this order. Electron, proton, neutron. So the order for number 2 is electron, proton, neutron. Number 3, what force keeps the protons and neutrons in the nucleus? That's the nuclear force. So they're asking, what keeps these guys here hanging in here from flying out to the electrons? It's the nuclear force. And then it says, what caused this? This force is caused by the exchange of pions between protons and the neutrons. Okay, pions are little particles that are exchanged that hold them together. So otherwise, if it wasn't for the pions keeping these guys together, they would fly, the protons would fly out to the neutrons, because you know positive and negative attract. So otherwise they'd fly out, but the pions is those little particles, and they don't last long. They're just short, they have a short lifespan. Where am I at here? Number 4, what keeps the electrons orbiting around the nucleus? Okay, what keeps these electrons flying around here in this black line? That is the electromagnetic force. Number 4 is electromagnetic force, or you might have put electroweak force. Either answer is the same. Number 5, an atom is mostly empty space. Now, can you imagine this? It is so small we can't see it. We can't use a microscope to see it. It's beyond man's ability to see. And they say, well, it's so small you think it's nothing there. He says mostly empty space. So put this together. Matter, which should be you and me, or the trees, or the grass, or whatever, is made up of atoms, or animals, is made up of atoms. It's mostly empty space. Me empty? You empty? Think a little bit. I'm not sure. That's just, it's just the way God made things, that we as man, we just try to reach it. We just try to get it, and we just can't quite grasp it in our little minds. But that's true. Atom is basically empty, and we're made up of atoms. Number 6 is, it asks, an atom, its atomic number is 34. How many protons and electrons does it have? 34 and 34. 34 protons, 34 electrons. What is the symbol? And now you have to look at your chart, and the symbol should be Se. So 6 is 34 and 34, and Se. Number 7, you should have 10 protons, 10 electrons, and 10 neutrons. 10, 10, 10. All 3 of them are same. And that's for Ne. That's for, that's for 7A. It's 10, 10, 10. Okay, let me get you 7B. 26, 26, and 30. So 26 protons, 26 electrons, and 30 neutrons. And number C is 57 protons, 57 electrons, and 82 neutrons. A bunch of them guys. And then for D, you should have 12 protons, 12 electrons, and 12 neutrons. 12, 12, 12. Number 8, it says 2 atoms are isotopes. The first one is 18 protons and 20 neutrons. The second has 20 neutrons, 22 neutrons. How many protons does the second atom have? And your answer is the second atom has 18 protons. 18 protons is number 8's answer. Number 9, you had to say which symbols were isotopes. So you had to go back and check and see which one had a different number of neutrons from protons. So an isotope is when you have more brown dots than blue dots. Can you see that in color? Is that color for you? It is? Oh, great. Okay, the blue dots are the protons, the neutrons are brown dots. And so that means you have more brown ones than blue ones, then you have an isotope atom. He's not balanced, he's not stable. So I will tell you which ones are not stable in number 9. The 112SN would be the second one. The 124SN, which would be the fourth one. And in your book, the last one, 120SN. So all the SNs are unstable. The rest of them are. Number 10, you had to draw what the Bohr model for O atom would look like. And so if you was to draw this one, let me tell you what you would do. You would put 8 neutrons in the middle and 8 protons. And then in the first circle, you would put 2 in the first circle. You was going to put 8 in there. And so in the next one, you'd put 6. In the second circle, you'd put 6 of them. Okay? So I will come back to this and talk about this at the end of class. So your first answer for number 10, or your number 10, you should have had 8 in the middle of each kind, and then you should have put 8 in the outside, which would have put 2 in the first circle, 6 in the next circle. Number 11, you was to draw that one as well, a model for Mg, and it should have looked like this. You should have had 12 protons, 12 blue ones, and you should have had 13 neons, 13 brown ones if you use my colors, 13 of those, and then outside here you should have had 12 electrons, so you should have had 2 in the first circle, and you, let me see here, how many would you have had in the second circle? You should have put 8 in the next circle, is that right? 3, 24. The second circle should have had 8, so that would make you 10, and then the third circle should have had 2. Okay, you put 2 in the first one, 8 in the second one, and then 2 in this outside third circle. And if you didn't put the correct number in the circles, it's wrong. I will count it wrong on your test too. And you will need to, no, I'll get that later. Number 12. It says this away. Let me see if I can find that answer. What is the largest Bohr orbit of Uranus atom? The symbol for Uranus is U. How many electrons are in it? Okay, the largest Bohr orbit is the 5th one, and there are 32 electrons in it. And you should have been able to find that answer on by figuring that out. By putting 2, 8, 18, 32, and then in the 5th circle, you would have put 32 of them again. The largest Bohr orbit is the 5th one, and there are 32 electrons in it. That is for Uranus. Number 13, it says, since pions have a very short lifetime, the stronger nuclear force can only act over very tiny distances. Okay, pions don't have a long, so they can't reach out far. They're just real short and they're dead. They're done. And number 14, 98 RU. I don't know what the question was, but the answer is 98 RU. That would be the symbol. And next one, number 15. Okay, again, it asks the question. You should have had 125 XE. 125 XE. Maybe I should be writing these on the board. Number 15. Oh yeah, that was 14A and 14B. Maybe I should do that. 14A is 98 RU. And the other one is 125 XE. 125 XE. That's for number 14. And number 15, you should have had 208 TI. 208 TI. Can you see that? Oh, barely. Erase The next one in 15B is 220 Rn. 220 Rn. Hey, you know what? 15 may be TL. I'm not sure. It might not be TI. It's just a straight line. Sorry. It's going to be TL. I read that wrong. 15A. Number 16 is gamma decay. Gamma decay. And number 17 is 2.5 grams. 2.5 grams. And number 18 is 0.125. Or maybe you had 1/8. You could have had 1/8 or 0.125. I guess you could put 0.125. Let's keep going here. 19 has got, why is radioactive dating unreliable in most situations? Why can't you use radioactive dating to figure out how old this rock is? Well, the reason is radioactive dating is usually unreliable because assumptions must be made as its original condition of the object. Thus, assumptions are usually wrong. Okay, you have to assume that the original object had this much in it of this chemical. And usually when you assume, you're wrong. Number 20. List the 3 types of radioactive particles discussed in this model in the order of their ability to travel through matter. Okay, they can travel through matter. The first one, the alpha particles pass through the least amount of matter before stopping. Alpha can just go through a little bit, alpha decay. Beta particles are next, and gamma rays pass through the most matter before stopping. Alpha first, beta second, and gamma third. Done. Now, I'm going to have a little bit of review, and you can turn to page 324. It won't be a lot, but in your textbooks, 324. Page 324. It's got vital information in there. And what I want to talk to you about is this picture of the Bohr model. And that is B-O-H-R. It's Bohr. It's B-O-R. The H is silent. When you think of the atom, you should think of 3 parts. You should think of protons, electrons, and neutrons. And by now, I hope I've talked enough about them that you know what they are. And just automatically, boom, you can tell me that the nucleus, the center, contains what? Protons and electrons? No. Protons and neutrons are in the center. That's the nucleus. The electrons are outside. And the first one, this is what I want to get to. You have that little chart on top of the page, and on that chart it tells you that in the first circle around the atom you'll have 2 electrons. And if that's all the atom has, then that's all you'll have. But if it has more, then in the second circle you can put up to 8 of them guys. Okay, so if it just has a total of 10, you'll put 2 in the first one, 8 in the second one, and you're done. But if it has more than 10, then you have to go to the third circle. And then you can put up to 18 in the third circle. Now how Bohr, that's a man's name, how he came up with this, don't ask me to explain that because I don't know. You figure that out in college or no, you go search it out right now with encyclopedias. I don't know how he come up, but the next one has 18. So you start out with 2 and 8 and then 18. So you do the math there. 2 and 8 is 10, 18 is 28. So if your chemical or your whatever you have, if it doesn't have more than 28, you can get them all in the first 3 circles. But if it's bigger than 28, you'll have to draw the 4th circle, which I didn't draw. And the 4th circle you can put 32 in. So now you add these all up, and 28 plus 32 is going to make you 28 be 30, make you 60. If your atom doesn't have more than 60 electrons, you can get them in 4. But if it has more than 60, you have to go to the next one, and that has 50. So that means you could get 120 electrons total. And I guess, I don't know what, in the sixth one, I don't know how many you put in there. A chart doesn't go that far. Maybe there is no atom that has that many. I don't know that one. One more thing I'm going to brush up to you is the decay. That is a little bit important that you will need to know just a little bit about the decay. If you have a decay, if any time that you have, let me see if I can find this. It is on page 328. Go to the bottom, page 328. You have beta decay and alpha decay. And it's a radioactivity that happens in the atom. If you have an alpha decay, that's the second example. If you look at your book, it's on the right-hand side of the page. You see that there are 2 neutrons and 2 protons that separate. In the alpha decay, you lose 2 out of this, 2 of each. Okay? Now that's not true for the others, but if you have an alpha decay in your product, you will lose 2 of each of these guys will come out, and it shows you how they come out. The alpha and in the alpha decay, there'll be 2 protons and 2 neutrons. Every time it'll be the same amount. So you need to get that in your head. For alpha decay, you lose 2 protons and 2 neutrons. Okay? So that means a daughter product with 2 fewer neutrons and 2 fewer protons. That's your daughter product, because 2 separate out. Now if you have the beta decay, now I should have maybe explained that one first, but in beta decay, an unstable nucleus reduces its number of neutrons and increases its number of protons by ejecting an electron or beta particle. Okay, the electron, it throws an electron out, and one of the neutrons turns into a proton. It says in beta decay, an unstable nucleus reduces its number of neutrons and increases the number of protons. Okay, so what happens is, it doesn't say that, but a neutron becomes a proton. A brown one becomes a blue one, and then you have a different number, and that ejects an electron out. And that's that little bullet we talked about, how it's dangerous, it destroys. It shows you the picture there of the beta decay on page 328 at the bottom. So know those 2 diagrams. On 324, on 328, it will be helpful for your test. And you only have 10 questions on your test, and when you pick up your packet this weekend here at school, you should have your science test in there. And you enjoy doing the test. See you.